Good afternoon, everyone. This is Rakesh Rao, Executive Editor of ASAP Info Global Group, welcoming you all for today's virtual panel discussion titled Future Ready Chemical Manufacturing. This webinar is organized by Smart Manufacturing and Enterprises along with Future Factory Expo 2026. Before we proceed, in brief, let me explain the agenda of today. After the opening remarks and a short presentation, we will have a 60 minutes panel discussion followed by a few questions from the audience. So I request all the participants to type in their questions in the chat box during the panel discussion is on so that we can take your queries and ask them to the panelists towards the end. So with this short description, let me share a few slides with you explaining the organization and smart manufacturing, what we do. Smart manufacturing was formerly known as IPF, Industrial Product Finder, and it is more than 54-year-old magazine and caters to around 2 lakh readers every month through magazines and the website. IPF covers the entire spectrum of manufacturing, right from latest technology to government policies to business strategy, and offers an assortment of news, views, interviews, and well-researched articles. SME is widely circulated in manufacturing and engineering sectors such as automotive, process industries, chemicals, pharma, electrical electronics, metalworking, and defense and aerospace, among others. We have presence across the major cities like Mumbai, Pune, Bangalore, Kolkata, Chennai, Ahmedabad. So in addition to what we do regularly every month, we also come out with India's only top 100 engineering companies special during the every year. That is this going to be in month of October. And also we serve the global audience through our special editions such as India Next, that is Hanover Special Germany. And we are part of ASAP Info Global Group, which publishes magazines such as Indian Textile Journal, Construction World, Equipment India, Indian Cement Review, and Infrastructure Today, along with conferences and exhibitions such as Cement Expo, 3i Expo, Rasta Expo, Infrastructure Today Conclave. And Smart Manufacturing and Enterprises will be hosting the Future Factory Expo in the month of November, that is on 3rd and 4th of November at NESCO, Bombay. And the aim is to make Indian factories future ready. And we are going to do this in a three-way format where we will be having exhibition. Then we also have a thought leadership conference and industry excellence award. So the intention is to bring all the stakeholders under one roof. On one side, you have the manufacturing companies, and on the other, you have the vendors or the supplier, the technology supplier, and we also have the policy makers and the consultants. So we have a almost like 360-degree consultation or the discussion on the various aspects of the manufacturing and how do you make it more future ready and competitive globally. So that's the intention. And through our awards, we will be awarding not just the best performing manufacturing company, but we will also have awards within the factory categories like smart factories, green factories, and then SATA workplace safety awards. So these are the multiple awards that we'll be giving. And to build up to the event, we have been organizing multiple, on ground as well as online events. Like in the month of February, we had done SME conference in the National Stock Exchange, BKC, called a Smart Manufacturing Conclave. Then we have been doing CXO roundtables. In the month of April, we had conducted it in the Pune at Maratha Chambers of Commerce and Industry, and in Bombay on July 9th, recently at Geo World Convention Center. And the next CXO roundtable is scheduled for in Mumbai on August 19th at NESCO Goregaon. We are also hosting a series of webinars every month discussing different aspects of industrialization and automation and manufacturing excellence. And today's event is a part of this endeavor. And if anybody wants to be a partner with Future Factory Expo, please feel free to contact us. So with this, let me move on to our main agenda of the day, that is a panel discussion. The chemical industry, as everybody knows, operates under complex and hazardous conditions, making precise process control essential. Automation supports real-time monitoring, batch traceability, regulatory compliance, energy optimization, dosage accuracy, and predictive maintenance, among others. However, adoption remains constrained by legacy equipment, fragmented system, high upfront cost, uncertain ROI, digital skill gaps, etc. Today's discussion will explore how automation and digital tools can make chemical plants safer, smarter, and more sustainable. Our guests for today's events are Mr. Abhishek Srivastava from Aditya Birla Group, then Dr. Subhash Singh Punjabi from Deepak Fertilizers and Petrochemicals Corporation Limited, Mr. N.C. Chakravarti from Reliance Industries Limited, and Mr. Renu Raj from Tata Chemicals Limited. The session will be moderated by Mr. Subodh Jindal, Member Editorial Advisory Board of Smart Manufacturing and Enterprises. So before I hand over the uh, platform to Mr. Jindal to carry and take forward the panel discussion, I would like to introduce him and all the esteemed panelists. So Mr. Jindal is a senior leader with 30 plus years of successful professional experience in managing businesses and organizations with P&L responsibility in India, Asia, and at a global stage. Over the last 10 years, he has been leading some of the Fortune 500 organizations as MD, CEO, board member. He is a certified Six Sigma Black Belt. Previously, he has held senior positions in companies such as Stanley Black Decker, 3M India, Thermo Fisher Scientific, and Steer Engineering, among others. Then we have our first speaker, Mr. Abhishek Srivastava, who is an assistant VP and head of Agentic AI, Industry 4.0, and digital platforms at Aditya Birla Group, where he leads enterprise-wide AI and digital transformation initiatives across manufacturing businesses spanning metals, cement, paints, chemicals, and textile. He has over 20 years of experience across Aditya Birla Group, Capgemini Engineering, Bosch, and NTPC. Mr. Srivastava has built a career at the intersection of Industry 4.0, IoT, and applied AI, driving large-scale digital transformation program, building next-generation agentic AI platform for manufacturing, and advising at the C-suite level on technology strategy. Then our next speaker is Mr. Subhash Singh. He is a visionary leader with over 3 decades of experience driving digital transformation across manufacturing, auto, pharma, and chemical industries. As a Chief Information Security Officer and Head of Enterprise Architect at Deepak Fertilizers and Petrochemicals Corporation Limited, he leads strategic initiatives including Industry X.0 transformation. He is renowned for turnover expertise. He excels in aligning technology with business goals, enhancing customer experience, and ensuring security, quality, and agility. Our next speaker, Mr. N.C. Chakrabarti, is a data enthusiast and the Vice President of Smart Manufacturing Technologies at Reliance Industries Limited. With over 3 decades of diverse experience, he spearheads Reliance Industries Industry 4.0 initiatives. He leverages AI, ML, and manufacturing data, supplemented by deep domain knowledge to forecast asset performance and drive efficiency across global scale continuous operation. And we have Mr. Renu Raj as the VP Manufacturing. Renu Raj works on ensuring safe, sufficient, and sustainable operations for all Tata Chemicals plants in India, including the flagship Mithapur Industrial Complex and town. Before this role in manufacturing, he was CEO, Energy and Battery Business Unit at Tata Chemicals for over 7 years. Mr. Raj joined Tata Group in 1996 and has played a key role in setting up multiple technology ventures within the group. He is passionate about emerging technologies and impact on businesses and society. So, on behalf of Smart Manufacturing and Enterprises and Future Factories Expo, I would like to welcome you all for this today's very important discussion. With this, I would now hand it over to Mr. Jindal for a 60-minute panel discussion. And as I mentioned to all panelists, please type in your question in the chat box as we move along with the panel discussion. Over to you, Mr. Jindal.
Thank you, Mr. Rao, for a wonderful introduction to our esteemed guest and panelists, and setting the stage for the this important session, right? Without much ado, why personally it is also very important, because I do have a background in the chemistry in the graduation, so that's very close. And we are discussing this, having this wonderful discussion amongst, a very large uncertainties given the current geopolitical situations, what's happening around the world. A lot of talk about the energy, the alternate energy sources, and many things. And chemical industry is one which is definitely going to be shaping the world from the future energy point of view, from the global requirement, more specifically from the India's sustainability, etc., etc. While this is a boon, there is also challenges which chemical industry faces, and also the industry 4.0 has been in 4.0 has been in talk for almost a decade now, but unfortunately, the adoption and movement to compliance has been rather slow than what we have expected. Given this background, today we are talking with this panel discussion is an important one, and we'll largely focus on the chemical industry moving forward, future ready chemical manufacturing. Largely discussion points around 4 topics. One is how changing manufacturing landscape in chemical process industry amid rising pressure cost, compliance, quality, safety, and sustainability. Very, very important. Importance of automation solutions for improving safety, traceability, energy optimization, process efficiency, carbon footprint reduction, etc. Overcoming the adoption barriers such as cost, legacy systems, and skill gaps. And how do we build a future-ready chemical factory, which is compliant and also kind of take care of all the challenges of current and the future. As Mr. Rao mentioned, we will be doing this through panel guided sessions. And during the first session, which is focused on building the digital foundation for chemical manufacturing, where the focus is from plant modernization to enterprise-wide digital transformation. May I request Mr. Raj to take this question, which says what chemical manufacturers today face increasing pressure to improve productivity while maintaining stringent standards for safety, quality, and regulatory compliance. How is automation helping plant leaders balance these often competing priorities? Mr. Raj?
Yeah. I would say that automation to a large extent started with the premise of replacing people with machines, thereby improving, among other things, throughput. But today we have reached a stage where automation has gone far beyond that with the help of digital and the sensors that we have. Nowadays, we are finding that these are less trade-offs, but they're actually connecting and supporting each other in a sense. So, for example, with interlocks, almost continuous detection of hazardous gases, for example, automated trips, etc., we are finding that safety and throughput is much less of a trade-off rather than enabling the plant to run at certain true design conditions. We have in process plants itself, we have put up, for example, golden batch rules. We have put up states where designed to follow or not, or more automated loops. So we have essentially ways of running it in safe, but also high productive paths. And the same thing goes for quality. For example, instead of post-facto inspection, there is a lot of prevention which is actually happening with inline analyzers, So we are able to, for example, fine-tune and look at particle size distribution much more carefully and make sure that the conditions wherever they drift are in line corrected so that the final output is within a narrow band. And this is something that has helped us, for example, when we deal with powders, come out with multiple variants as well. So in some sense, it's not just throughput, but it is also enabling new products and new variants as well. Compliance is fantastic, and I think the government has taken a lot of very interesting steps. There are already online connected sensors in some cases, which directly give real-time information to the regulators. Even for the ones which are offline, compliance we are now finding more as a byproduct and not a scramble at the end to try to gather data and prove compliance. So with automated historians and data coming right off the bat, these are things which are getting increasingly automated, and my belief is that in future time, this will be something which is automatically done, and the reporting to regulators or other concerned parties will be completely requiring no intervention from humans. The other part I would say is that in some sense, we are talking about removing people from more hazardous exposures, whether it comes to safety, whether it comes to areas where there is heat, there is other materials. The automation is actually helping in multiple ways there. So I would say that it is actually becoming less and less of a one versus the other, and far more of a connective tissue, which is sort of building safety, quality, cost benefits, higher productivity, and compliance in situ into the process itself.
That's right. Thanks, Mr. Raj. That's very good. In fact, so in summary, what you're saying is automation is not competing with the compliance or safety, rather it is just adding it. May I just add quickly, does the automation from your experiences also help connectivity between the different plants across the world and across the geographies? Because then the plants can talk much faster and then also drive rather than doing the jobs locally. Is that also a benefit?
It's in the roadmap, is what I would say. Most of the automation, you did mention about the age of chemical plants.
Correct.
Right? So the plant that I'm right now sitting in is more than 80 years old. So you have a situation where there are parts of the plant which are really old and parts which are very new. And the large amount of the digital and automation parts is also in some sense localized pockets.
Right.
But the future roadmap is exactly what you mentioned. It's about connecting these islands in manners so that they can start leveraging these parts. And very similar operations we use in terms of models, in terms of benchmarks across sections in other plants also in other geographies as well. But right now, I mean, it's not that there is a real-time connection or an advantage that we see for that just yet.
Right. Thank you. Moving on, Dr. Singh, if I can bring you in for the discussion. And one of the observation is many chemical plants still operate with legacy control systems that were never designed for today's digital environment. So what do you think is the practical roadmap would you recommend for modernizing these plants while ensuring business continuity, safety, and sustainability? Basically, what could be the real action, act to do kind of actions for modernizing these plants?
Thank you very much, Subodhji, for this very important question. Now, you see what you are asking, you said many, but I am saying all. Only a new plant, if somebody says they are having a green-based plant, suppose, when we say, then they can have a modern systems and maybe the digital-ready systems. Otherwise, all chemical plants are in this zone. Other point here, as you are asking me for the roadmap. So again, my viewpoint is that it is a mandate to go ahead with the digital transformation, Industry 4.0, connected shop floor. Otherwise, they can't be in the race. So it's a very important. Now coming down to the roadmap, what I feel, given the all this, we talk about the old plant, the complexity, safety, availability. When we talk about any plant, availability is very important. It's a shop floor, correct? So plant should be first protect. Whatever is there, how to protect. then connect it, then try to optimize it, and then transform. Because you can't do everything together. If we decide that someone has came up and now we are doing all rip and replace approach, everything will replace, which is first thing is very expensive, not practicable. Other thing is disruptive because everything is running in particular form. You can't do that at a time. So my recommendation is it should have a phased approach. In that first whatever is there, first protect it, which is very important because we've seen that various different type of attacks are coming up. First is you see what you have got. Start with comprehensive assessment because believe me, nobody knows exact OT inventory. What are there in their plant? Exactly. Nobody knows. This is a very bold statement, but it is. Because earlier, when we say OT, it is a term we are talking since from last 5, 6, 7 years. But OT is there since from ages. And this name was not given to it. When we talk about PLC, so we know PLC in India, in the 80s, we have seen. Correct. So it is since then, and now we are saying PLC as OT. So that is the major part. Start with comprehensive assessment. What are your DCS? What is the PLC? What are the SCADAs? What are the SIS environment? Asset criticality and life cycle, which is very important. Then tag that asset with criticality. When we say in the chemical factory, we talk about single line equipment for your normal maintenance. Here you tag it with the criticality. Then cybersecurity posture. What is there in the threats are there. Safety regulation, regulatory requirement, which I don't have to tell, it is required and everybody is doing that. Energy and emission baseline, we talk about sustainability. So that is a very important first. So first point is to reduce risk and not replace. Just reduce it. Check where it is and reduce that risk. Have some coverage to it, we can say. So key action, what I feel in the first phase is OT asset inventory, segment IT and OT network is very important. Earlier, that we said that our OT environment is in one cage, so very air gap, and every person is going there and do something. But you want to transform, you want to do the digital transformation, that will not work. So you have to do IT OT converge. So segment it and do. Don't directly do it. Patch harden system wherever possible. Implement end of support life. Now end of support assets are there. So you will understand that in IT, normally we say that we will replace our laptops, desktops, servers in a period, 3 year, 4 year, 5 year, 6 year, not more than that, any company. But in OT, we have got assets for 15 years, 20 years, because it is connected to some machine. And because of that, we are not changing that. Correct? Because we can't change. So it's a 20 years, 25 years. So there we have to see how we have to do the end of support, how we can get that, what is the point of failures that we need to check. That are important. Then we talk about the connect. Then we can say how now next step is, then legacy plant suffers from isolated systems. So I talk about the air gap system. So now you try to do connect. So before connecting, before having that digital transformation, first secure it where you are. Then connect it with the system which are fragmented, deploy industrial data platform, introduce standardized communication protocol. Correct? Connect historians. In chemical industries, we have seen various people doesn't have historian in place. Connect historian. There are various systems available. You take whatsoever is suitable to you, but historization is very important for your digital transformation. And then we have to have a centralized dashboard, modernized field. So main thing here is, rather than replacing everything, use gateways and middleware, because replacing will not work.
Right.
The objective is to make plant data accessible and actionable. That is very important. Then you talk about the third phase when we say modernize critical control system. Because in this phase 1 and 2, what I am saying, we talk about the protect and connect. In this, you will get some output. You will get some details now. Then you talk about modernize, then enable it, and you will get, then last is sustainability. That is sustainability by design. How we can do, what we are getting, real-time energy monitoring, which is very important in any chemical industry, heat stream optimization, emission tracking, every day we have to do water consumption, electrification, carbon. These are the things which all chemical plants discover from the fastest sustainability goal, which is required. So, and in my view, there are 5 P's. Critical functions are 5 P's: people, process, platform, protection, and partnership. Now, partnership, when we say, there are two things again. It's very important. We have to partner with OEMs. We have to partner with shop floor. Totally, each person who is on that particular machine, who is actually working, we have to partner with them. Partner with system integrator, partner with technology partner, technology integrators, technology providers. There you will get actual details of this. So in a crux, what I say is that modernize progressively, not disruptively. Secure the plant first. Security is very important because when you talk about chemical plants, human safety is also a very big part for it. Correct. Create a connected digital foundation, then modernize, and then leverage data and AI. So that is the last part. Because what happens nowadays, what I've seen, Subodhji, is that very many people, they compare with somebody and they say we want to do this, which is very dangerous. Very dangerous. Everybody has got their own appetite. First check where you are and then go. Have a plan and then go. So that is that way I can say that should be the prioritization, that should be the roadmap for each industry. Thank you.
Thanks, Dr. Singh, for putting us together. And the key takeaways is you define very beautifully the 4 stages, which is basically protecting, connecting, optimizing, and then transforming, which is part of your sustainability. And then take care of the 5 P's, which is the people, process, platform, protection, and partnership, right? Fantastic.
Right.
And with this, we move on to the next very important topic again. And I'll invite Mr. Srivastava to share his views, which is while the benefits of Industry 4.0 are being widely recognized, many automation initiatives struggle to move beyond the pilot project. And we have seen it across industry and more so in the chemical industry. In your opinion, what differentiate organizations that successfully scale digital transformation across multiple manufacturing sites? This kind of coming from the first question as well, that in your opinion, what differentiate the organizations? What is the different blood in these organizations and the philosophy in successfully digital transformation across multiple manufacturing sites? Mr. Srivastava, your views, please.
Yeah. Thanks, Mr. Subhash. I mean, so far from my experience, technology has never been a challenge, right? When it comes to kind of implementation of technology, right? What I have felt the biggest challenge is adoption and sustaining that what has been implemented, right? So what specifically from chemical manufacturing perspective, I'll give some examples. So even if you change one small parameter, right, and then thinking that one particular outcome will change, actually a hell lot of other things will also change, right? So how this complexity is taken care by your IT or technology or AI solution, that is very important. And that requires a lot of patience, perseverance, and trusting that yes, it will be achieved. So the moment we implement such technologies, it doesn't happen overnight or in 1 month, right? So over a sustained period of 3 to 6 months, you will see that change, that the complexity, the nuances, the nitty-gritties of chemical manufacturing is being now understood by, let's say, AI models, and they start giving results, right? So right from the shop floor employee till the CXO level, everyone should understand this and appreciate it. If one person or one layer doesn't understand, that doesn't support this patience and perseverance and constant upgradation of the implemented technology, it will not happen. Specifically in the context of chemical manufacturing, I don't think it is going to happen. I'll give you another example where we were implementing a technology, I mean solution called Golden Batch. So we achieved what we wanted, from quality perspective, but a lot of other things, let's say energy consumption or reliability, got impacted, right? So how do we balance it, and in what duration we will be able to balance was the challenge. And the project got sold, and then we reinitiated it with right narrative, right? So these are the challenges, and specifically how the technology takes care of complexity. And second thing is definitely building a common data foundation, especially in the context of ABG. When in we let's say we have more than one chemical manufacturing plants, so whether all plants are moving together, right? So there is no duplication, there is no kind of multiple use cases coming out from same kind of problem statements, where the data foundation is common, where the one plant is learning from the implementation of other plants, right? So those things are taken care, definitely technology will thrive. If it's not taken care, it will be a chaos at the end of the day. Yeah, back to you, Subodh.
Right, Abhishek. But no, very well said, and I think your experience in the industry speaks volumes about from your experience. In addition to that, if I have to just ask you something, what have you faced, and do you believe there is something to do with the culture of the organization when we are moving towards transformation of the chemical plants and moving towards digitization? Do you think the cultural shift has to happen, and is that an important piece? You talked about from CSO to
So
shop floor.
yeah, I would say culture was a challenge earlier, let's say
Okay,
5 years ago. That's my
okay,
personal preference. But today,
right.
everyone, because more than culture, the mindset, right? So
Mm,
today, since many employees and everyone is using digital in their personal life and all, so they
mm,
have understood the impact, right?
mm,
So
mm.
that cultural kind of resistance has reduced drastically. uh,
Okay.
the only challenge is somewhat fear of failure or fear of losing the respect or job, right? That
Mm,
still remains. But
mm,
how do we tackle that? That also we have kind of structured and understood, right? So
mm,
I hope many organizations would have faced those kind of challenges. Cultural shift has to happen, then the fear of job loss has to be managed. But
mm,
now there are well-oiled, I would say, framework and methodologies to manage that. Right.
mm.
I will not say it has completely gone and then cultural shift is not required, or that fear is not there at all. While those things have reduced drastically, at the same time, organizations have learned to manage that. Right.
Hmm.
So,
Hmm.
fundamentally, it's less as of now.
Right. Thank you, Mr. Abhishek. And moving to the next question and situation, Mr. Chakravarti, I will like to draw your opinion around this. The chemical process industry generates enormous volumes of operational data. We all know that, right? Every single minute, every single second, we are generating tons of data. How are AI, machine learning, and advanced analytics changing the way manufacturers improve process stability, asset reliability, and overall plant performance? Mr. Chakravarti?
Yeah, thank you. Thank you. It's great to be here. So when we talk about chemical process industry, we are dealing with a deluge of data.
Right.
A single world-class plant can have anywhere from 50,000 to 100,000 tags streaming data every second into data historian. And historically, we used to use this data reactively for somewhat like creating report, doing postmortem RCA. However, today with machine learning AI, these are fundamentally changing the game by shifting us from the reactive troubleshooting to the predictive and prescriptive orchestration. I will break down this into the three areas that you talked about, like process stability, asset reliability, and overall plant performance. The first, the process stability. In our traditional regulatory process control, advanced process control, they are heavily relying on linear models. But our chemical process, as per example, a highly exothermic polymer process, a complex distillation column, they are all inherently nonlinear and dynamic.
Right.
So we are now using hybrid modeling. This is where we are combining traditional first principle physics-based model like mass and energy balance with the deep learning architecture like LSTM. This model injects high frequency data to predict the different process conditions like process drift, the runaway condition of the reactor hours before they start showing the visibility to us. And this allows us to do a micro adjustment in the set point to maintain our process stability. If I talk about the second point, like as you talked about the asset reliability, presently we are moving away from the simple predictive maintenance towards a holistic asset health management. The machine learning models, particularly the unsupervised autoencoder models, looks the multivariate correlation among the variables. Just to give an example, when you talk about a compressor or rotating asset, it does not only look at the temperature of the bearing or the vibration that we used to do in traditional predictive maintenance. Currently, it looks at on the asset parameter along with the process parameter like temperature, pressure, flow rate, and it looks at simultaneously. And by detecting the subtle deviation in this multivariate relationship, the models can catch the compressor health or maybe fouling of the heat exchanger hours before the failure happens. So this actually completely rewrites how we are looking at the plant turnarounds. Every year we do the turnarounds and asset health. The third one, the plant performance. So overall plant performance is nothing but optimization. The reinforcement learning, advanced analytics are now being applied to entire production trains to optimize the energy consumption, to improve the yield. To give an example, in a chemical process plant, the energies, specifically the steam and electricity, these are massive variable cost. The AI can now dynamically optimize this in terms of checking the fuel to air ratio into the utility of boilers, making a trade-off between which type of fuel to fire now, or whether I should generate the electricity from my in-house GTs, or I will be importing it from grid, or whether I will be using my non-traditional energies from solars that we are generating when to use. So all these things are being now done in real time using the advanced analytics. So AI is transforming us to look holistically in real time, and thus it is improving our EBITDA margin. Thanks a lot. I'll pass on back to you, Mr. Sunil.
Thank you, Chakravarti, and no wonder you could want to call yourselves as a data enthusiast. And the key takeaway is that in spite of having an enormous data, I think the beauty lies is how do we move from reactive troubleshooting to reliable predictability in all sorts, right? So thank you with that. We kind of close the session one, and Mr. Rakesh, there are few questions raised of hands. Do you want to take these 3 questions now or towards the end of the session?
We will take it towards the end.
Okay, fantastic. Now, end of the day, we talked about the hard realities and the technology side and the AI side of how can we transform the chemical plants and from your experience. But end of the day, it's important to understand how these digital investments shape up into the long-term business values, delivering secure, sustainable, and measurable transformation. End of the day, these will require sustained investments and which should translate into a long-term business value propositions. End of the day, we should see the benefits into the P&Ls at some point of time and sustainable. Let's say, Mr. Raj, if I draw you in back and talk about the automation projects are occupied by improvements in efficiency, but their real success is measured on the shop floor. From a manufacturing leader's perspective, what operational metrics or business outcomes should companies track to evaluate whether their automation investments are truly delivering value? This is something I'm sure you would have faced this, done this, or asked this within your organization, and that's very pertinent. How really these just more talks, or these are really deliverables metrics? So, Mr. Rao.
Yeah, this is a very interesting question, and something that I think which we have struggled with in many parts of the company. There are some sectors and some places, for example, in the marketing or the retail side of things, where the benchmarking is easy. Most of the industries around them do certain things. Justification, ROI comes very naturally because X is doing it, Y is doing it. Why are we not doing it is the question. But when it comes to core manufacturing, and I think that's where, especially when we look across other companies in India, this is where I think such panels and discussions can also strengthen that belief in terms of how we should be going lockstep and barrel. Here, we have to justify by hard numbers, partly sometimes because the technology itself is hyped up, partly because some of the projects actually do not work out, as was also earlier pointed out by one of my fellow panelists. And the more closer to the edge you get, the more newer technologies you try, then you get into the realm of hit rates. So one thing that has worked for us is that we look at overall as a package, have we benefited? What is the efficiency improvement? What is the rupees crores quantification that we can do as far as digital projects as a whole is concerned? That sort of worked out because there will be some which will be in various stages of maturity, but at any particular point in time, we can we have come to a stage where you have sufficient amount of positives reported during the year compared to the cost and the investments have come. Right? So hopefully that will remain that way. It is not direct in that sense. This was a much tougher issue 5 years ago, and I would say thanks to COVID, we sort of had a sudden flurry of digital projects and extensions of this happening all around. And today we have reached a stage where it is much easier as a portfolio to justify investment versus benefits. But that said, when we go down to the nitty-gritty of things, we still need to make sense of each project. And there we look at some projects from either a compliance or a community benefit or some kind of things. We do not look for metrics, but wherever it is touching core operations, we end up looking at metrics. I would say one part is looking at things like availability, performance, etc. And we try to bring it closer and closer to where the real impact of the intervention we are doing is. But that said, in many cases, there are multiple factors. The whole world changes very fast around us. So it's sort of very hard to pinpoint the effect of one intervention and say that this can be directly attributed to that. But that said, we try to come close and we still stick to KPIs which can be sort of monitored over time and try to see whether there is a step change or over a period of time change. So that's one. And other metrics are similarly there, yield plus giveaway rates and things like that. Safety is again another area where we sometimes decide that okay, we will not look at ROI. We just look at the effect of the number of incidents that we are able to catch or the root cause analysis that we are able to do things. The other part I would say is very strong is two metrics which are specific to this. One is people in terms of adoption rate, how fast are they able to get onto the bandwagon and how much they are using it. So, for example, if it's an advisory, we regularly track how many times has the operator been following the advisory, which is giving a sense of understanding as to how much trust is being built in the system. And this was a challenge, again, as I said, 5 years ago, where people used to, I mean, after 20 years of trusting their judgment or the judgment of the expert who taught them, it is hard to suddenly say that, okay, there is a black box model or some inexplicably complicated nonlinear equation, which is going to tell me that this is what I need to do when the still reaches this particular condition. So this is something that is now come out with experience and practice, and this translates very well. It generates more confidence in future projects as well. The other part is also related to this, which is basically the scale velocity. That is, if we have one model established or one fix which is being done, how fast to similar plants, equipments, we are able to propagate it, not just in the plant, but also in other plants in India as well as in other geographies as well. And this is something which is a metric which is very nice to track. It gives us a feeling that it is not just one person's child. It is something that is finding with different owners a good degree of success. And these, I would say, are good metrics. And the people factor is something which is over a period of time fantastically important to us, because today, right now, I would say still it's a bolt-on. That is the operation, the data analysis, the IT infrastructure. These are all separate, discrete pieces which come together for a project and go back. But the data literacy is increasing, the confidence is increasing, and those are KPIs which sort of, at least on the digital side, we try to keep track, because that will help us go forward and do more things on this side. Yeah.
Thank you, Raj. I know that because all this critical transformation journey cannot be directly put it into the balance sheet and the P&L, as much as the CFOs will like to do that, right? But what you talked about is very important, that this is a journey and there are certain hard metrics and there are certain must-do metrics, like in terms of the compliances and the sustainabilities and this, which will, I also believe very strongly will flow back the benefits into the P&L over a period of time. Also, the other aspect could be looked at as saying this could be a survival investments, right? If we don't do this, 5 years down the line, those companies or the entrepreneurs won't exist because the customers won't come and buy from those plants and etc. Right? So these are, while as much as our CFOs will like to continue to push us to get that into the every dollar, penny spent into the P&L, but I think these are very important investments for the future and sustainability. Thank you. I move into the next, and I like to draw Mr. Chakravarti here. As manufacturers pursue lower energy consumption and reduce carbon emissions, how can automation, digital twins, and real-time processes optimization contribute to achieving both sustainability and profitable objectives? Little complicated, but I'm sure Mr. Chakravarti, you can help us understand this better.
Yeah, thank you once again. Actually, this is the defining challenge of our generation, I would say.
Right.
Historically, the sustainability is viewed as a compliance cost. But today, with the advanced automation, digital twins, these are proving that the carbon reduction and the margin maximization are actually two sides of same coin. And here is some of the way how many manufacturers are executing this at the plant level. I'll just talk about maybe 1-2 scenario. The first one, the thermodynamic digital twin for energy minimization. When people hear digital twin, normally they often picture a flashy 3D model. But in process industries, the digital twins that matter are dynamic thermodynamic model running in parallel with the live plant. So let me take one example. In a standard olefin cracker plant or a complex distillation train, the heating, cooling this process stream across accounts a massive percentage of the plant total carbon footprint. Heating and cooling mainly is done using the exchanging the heat across the process streams and also taking some of the remaining requirement from the external utilities. So a thermodynamic digital twin normally constantly calculates the real-time fouling factor of heat exchangers. It tells the control system exactly when a heat exchanger to be cleaned, or if I have a multiple options of routing the different streams into the different process streams, it tells us which streams to be routed to which exchangers to minimize the amount of utility that we are bringing from outside, or mainly satisfying the requirement of the heating and cooling among the process streams only. And this improves our total emission, total carbon footprint. If I talk about another example, like our real-time optimization emission control, one past in the previously we used to have a objective function in our real-time optimization as the maximizing the productivity, maximizing the throughput. But nowadays, with the help of computational feasibility, adding new computation, we are adding new objective to our real-time optimization that increase the throughput or productivity subject to minimum carbon requirement or minimum emission. And so because of that, the availability of models, availability of data, and since we are able to run the models in real time, taking different factors from the plant, from financial the data, it is continuously optimizing our processes in terms of energy. And so it is not only improving our the throughput and productivity, it is also looking at the doing that at a minimum emission control.
Right.
And third one, once again, very quickly, is that our advanced automation things. So process plants normally are designed at for the steady state operations. Frequent transitions introduces massive instability, and that instability causes a lot of more requirement of energies. And at present, having the advanced regulatory control automation system, this is allowing us to prevent all these transition upsets and ultimately removing requirement of more energy. So ultimately, the optimization is done keeping in mind that I need to do the optimization with minimum amount of energy requirement. So that is being achieved through the advanced analytics nowadays, as usual. So ultimately, all the advanced analytics, it is improving efficiency. And efficiency is nothing but decarbonization. Unfortunately, efficiency is highly profitable with the help of the data-based model. Thank you.
Thank you, Mr. Chakravarti. Beautifully put how the digital twin is really helping both from the profitability as well as from the optimization, etc. At this time, I will like to bring in Mr. Singh, Dr. Singh. As the chemical manufacturers become increasingly connected through the industrial IoT, cloud platforms and remote operations, how should companies strike the right balance between greater automation and stronger cybersecurity? And in addition to this, which vulnerabilities deserve the highest attention today? Dr. Singh, no
So
problem.
see, automation is like buying a Ferrari for your factory. And cybersecurity is making sure you don't leave the keys with the hacker. The challenge today isn't choose between automation and cybersecurity. It's making sure, challenge is to making sure they accelerate together. We need digital transformation. We need all the modern technologies. But with that, the second side of your coin is cybersecurity. Hackers are there, they're waiting. So that balance is the challenge. So as chemical manufacturing increase connectivity through all these things, what you already talked, the goal should be automation with security by design. What happened? Not automation first and security afterward. But the reality is that because we are also user and we are also human being. So suppose I am talking something means I am doing 100% is not correct. Okay, I am also human. I also got pressure from my shop floor, from my management. Various times where we all do mistake is that we see that we have to do some automation which will show you result. We run behind that. And then we decide now we have done this, now we have to talk about the security, but it should not get hacked. So we have to say that not automation first and security later, but how it should be hand in hand. That is the thing. Now, three priorities are very critical for this. Secure your OT environment first through network segmentation, zero trust, continuous monitoring. There are technologies available. Protect your legacy systems because you know that legacy system has got by default vulnerabilities are there by default. Because when they are designed, it is not meant for this particular thing. But they are designed around 20 years back, 30 years back. Mainly in chemical industries, all plants are more than 30 years old. And people are taking old plant as such, which is working in the foreign countries. And we take old plant itself and we start using in our industry. Normally it happens. Strengthened remote access and third-party security. Now here, we might have heard, we all are in the same field, so might have heard various attacks. They are because of the third party. That is called supply chain attack. Normally, we do our work, we give total thrust to what we want to secure at our end, and we secure it. But there are the supply chain, there are the third party, there are the OEMs, there are the integrators with whom we are working. As I mentioned earlier, partnership. But that partnership should be seen with the securing it, secure your remote access and third-party security because remote access is must. Nowadays, we are into the field where we can't say that if something is happened, that engineer should fly from wherever. We are in Mumbai, we are in Dahej, we are in Gopalpur, Srikakulam, correct? Various places. Now, we can't say that engineer should fly. Because it will reduce the time, correct? It will just kill the time. So we have to ask them to come access our system and give us the solution. So for that remote access is required, but then we have to secure it, strengthen that remote access security, which is the major part. If you just see, you just give anything, maybe ChatGPT, Copilot, normal Google and ask the latest threats or latest attacks. Majority are because of this. 2 days back, I think yesterday or day before yesterday, your one company, a power company from South, has leaked their data, got leaked their data. The reason is something else, not their own. That is again third party. So you may go and just check that. You will understand what it is. Because normally what happens when we talk, we do ourselves, but we don't see outside. That is a very major thing what we need to see. The biggest vulnerability, you asked about what is the vulnerability? Biggest vulnerability are legacy OT system, IT/OT converge. We do IT/OT converge, which is mandatory for any transformation, for any digital transformation. It is mandatory. We have to do. But that are the biggest vulnerability where we have to check. Remote access pathways, supply chain risk, and human error. Now, when we talk about human error, so you see that other major part is your human. Human are because of their unawareness. What I have seen here, no, we talk about various things. Humans, they don't have a bad intention. Means it may be, but it's 0.01% human. 99.99% mistakes happen in the cybersecurity because of unawareness. Aware them, give them training, always send the maybe these flyers to them. What is happening outside? The way I given you example of yesterday's. So I will just give one suggestion to the audience here. What I do, they should do it. Correct. Make a summarized public facing whatsoever has declared. Now yesterday's incident, what I'm talking about, power plant is declared. So that is in public now. Correct. We have to make a summarized note of 1 page and publish it to all the members in your organization. So they will know this type of things are happening. Then you will get a support from them. Like you just said, and everybody knows, nobody will give your ATM code, ATM pin to anybody else. That they know. Similarly, other things they should be aware. Whenever they are going out from their home, they check their log, I think twice, thrice. If they are going for 8 days, 10 days, some tour. So these are the things they know. The same thing, some type of thing they should do in our organization. For that, we have to give them. So in a simple thing, if the key takeaway is there, greater connectivity should be matched by greater resilience. Now this is new word I'm using, resilience. Because nobody can say as of now that we are 100% secured. We all are may get attacked anytime. What we have to think over is that, yes, we will get attacked. That we should think over. And how resilient we are. How quick we can come out of it. How maybe the near to zero impact will happen to our data, to our operations and all that things. That is called greater resilience. So in the chemical industry, cybersecurity must be treated as an integral part of process safety, because a cyber incident can quickly become a safety for any chemical industry. It's a human safety. It's not just money. It's a human, which is invaluable, correct? Operations and environmental incidents, when we talk. So these are the, if we say that your production are down, it can count in a money terms, dollar terms. But your human safety, it's your brand. And it is again a big regulatory thing also. So we have to think over on that manner. Thank you very much, sir.
Right. No, you brought, Dr. Singh, very important point. Apart from the solutions and IT solutions, and we know that cybersecurity is very important along with the automation. But two important points what you brought out was, one was the discipline, the culture among the employees and everybody, and making those policies public so that everybody takes care of as a responsibility, and it's just not left to the system. And the other important aspect what you brought down was the resilience, which you defined as how quickly you can come back and don't
Correct.
give up the path, which makes important, especially for chemical industry, because human lives are directly attached to that.
Yes,
and that can lead to a huge losses if this is not, very, 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 very important. With this, I draw my attention back to Srivastav, Abhishek ji. We talked about technology, we can talked about a lot of availability, how industries is moving, but I believe technology alone cannot transform the manufacturing. Now, what do you feel how chemical companies should address the workforce readiness, the change management, and the skill development to maximize returns from the automation and the AI investment? How do we address this softer side, which while we call it softer side, but they are very, very important given assuming and given the technology is available.
Yeah, thanks, Mr. Subodh.
Yeah.
What I feel is definitely technology alone is not sufficient until, the workforce is not ready to, embrace it, right? So I will give you, the plants which I managed in ABG. We have a phased approach. So it's not, training the employees, making them ready for the technology is not an afterthought, which means once the technology is deployed, once the solution is deployed, let's train the employee, let's give them some hands-on, right? So earlier when we used to deploy DCS, SCADA, MES, right, those were the methodologies, mostly. But today, even before technology is deployed, we start engaging with the employees, right? We start doing the value discovery workshop. In ABG, we call it 3SM, Smart, Safe, Sustainable Manufacturing Workshops, which means think from these three angles. How do we make our plant smart? How do we make our plant safe? And then sustainable, right? And once those workshops are completed, we ask these shop floor employees and plant people, what do you think is the most important and pressing problem technology should solve, right? So it should come from them rather than we pushing it something. And then we give some initial training to them. But remember, even we have not started anything which we are deploying, but all these things are happening, right? And then we deploy the technology, and during that technology we set a KRA that whatever we have done before, kind of deploying the technology with these employees, how good they have become in terms of, contributing to design the solution itself, right? So if employees have started contributing, their ideas are flowing in when we are designing the solution, which means we have achieved the KRA which we wanted to achieve before the deployment, right? And
Right.
once the technology is getting deployed, another KRA is trust factor. So we say whether employees started trusting the technology what we are deploying. So the recommendation which technology is giving, how good those recommendations are that these employees are trusting and taking some actions, right? So if the trust factor score is low, which means we are not going in the right path, we have to do some corrective action before even, scaling up this technology, right? So once the trust factor is deployed, then we have to monitor the something we call value governance framework. We have to monitor whether it is really, technology is really generating value, where, both human and technology contributing and collaborating together, right?
Right.
So these are some of the soft KRA we call it. It's nowhere written in a book, but they help us a lot in terms of making the workforce ready, and it's more on the job readiness rather than off the job readiness. Definitely we do some trainings off the job, but those are also hands-on training. But how much employees are contributing in the design phase, validation phase, value governance phase, and even before before the technology start deployed, which is, value discovery workshop, these are the kind of soft KRAs we keep monitoring, and it helps us a lot in terms of, final outcome what we are expecting, both from technology perspective and from the human upgradation, skill upgradation perspective. So this is something which we do. Yes, back to
Thanks,
you.
Abhishek. Appreciate that. We have about 8 questions and raise of hand. But before I ask Rikesh to take these questions, one final common question to all my panelists, and not particular order, but Mr. Singh, it is a common question to all of you one by one. What, in your opinion, should be one strategic investment or which chemical companies or plants should be doing looking at next 3 years, which is so critical at this stage, both from the making them future ready and from taking this technology advancement? What one single, very crisp and short?
Okay.
I know it's a
So, sir,
difficult one, but
yeah,
I just want to do that. I know.
If you want just a bullet point, it's okay. But if you want explanation, then it will take some time. But
Right.
it's very simple and straightforward. It should be data-driven digital foundation for OT and plant operations securely. This is the crisp we can say. And just I will give you small example of why I'm saying, because
Right.
reason is very simple, sir. Now
Right.
everybody is talking about AI,
Right.
advanced automation, prediction, sustainability, autonomous operation, everything we're talking.
Right.
Just think over on what it is. It is on data, only on data, and that is real-time data, trusted data, correct? So everything is moving around data. So there are various things, Subodhji, that people have started their AI journey by default, and they are not getting result because data is not there properly. Data is something in silos, something missing, and data sufficiency is a word what people are using nowadays. That they have got thousands and lakhs of data, but what required it is not there. So that is
Right.
what data sufficiency. So I
Right.
think this is very important. And then secure OT architecture, organizations cannot fully leverage these capabilities without that. That is the only point in short we can say. Thank you.
Thank you. Mr. Chakravarti, what do you think should be the strategy, one single strategic priority?
Yeah.
in chemical-
Just to complement Mr. Panjabi's what he said about the data. I had one survey by one of the consulting company, famous. What they said is, we are actually historizing 70% of the available data. Out of that, only 30% of those data we are actually utilizing to create value. That means only 21% of the available data we are using, and rest are not, we are able to use it. So to complement Mr. Dr. Panjabi, just to talk about the real battleground is data contextualization also. The raw time series data without context
Yes.
is actually useless. So
Correct.
manufacturer who are owning today are the one investing in robust data infrastructure, bringing together the OT data, the OT data in addition to the DCS and PLC data, the data from design like PNID, PFD, the IT
Yeah.
data, transactional data. So every data has to be in a uniform platform, and that need to be produced to the users so that they create the value. That's the only things I'll talk about.
Right. And Abhishek, from your point of view, what one strategic priority or investment chemical company should do, keeping 3 years view for automation?
Yeah, so nothing new. I mean, I would just want to complement and add what Mr. Subodh and Mr. Chakravarti said. But in our parlance now, we are calling it knowledge engineering.
Knowledge.
I mean, in one term, I mean, just to summarize what both the gentlemen said, mainly the data plus contextualization plus context-aware knowledge, right? Because now coming up in the age of agentic AI and LLMs, it is quite possible for chemical manufacturing also to move towards knowledge engineering, right? I would not describe what it is. I mean, audience can figure it out. A lot of material is there, but mainly that's where we should start thinking now. And from Indian context also, right? I mean, many fresh engineers and graduates have joined years ago, but those experts will know more. I mean, in terms of physical presence, they will not be there in the plant, right? I mean, and that's where this knowledge engineering is actually becoming very important, right? So
Right. Very good. And last but not the least, Mr. Raj, what's your view? One priority, strategic priority?
He's already a data lover.
Yeah.
Mr. Raj?
Yeah. From my perspective, I think our people have spent a fair amount of time in building some of the data and basic models. At least in the next 3 years, and I'm speaking more for the context in which Tata Chemicals is operating, it may not be applicable for others as such. But one key area is to make sure that this trust element builds up, in the sense that right now, for example, there are black boxes and there are answers coming out. People are to some extent going in because experience is proving that this is working out in most cases. But that said, it's sometimes when we try to test new processes and new equipments, there are regimes or data points which we have not captured, which create issues as well. So I think bridging that gap and making sure that one, people go from the place where they are, which is basically, okay, I can start using this. Two, where they can believe it, question it, improve it. And that has to be done by the teams themselves in the operations as well as maintenance and plant, etc., rather than a separate set of data engineers or IT experts or vendors coming in and pitching for ideas. That part is where I would see the next 2-3 years journey. And for that, we are finding, for example, GenAI being quite great. It's not good at making those ML models, but actually in terms of explaining and troubleshooting and giving, once the advice is there, as to say why the advice may be more palatable, or rather explaining the black box situation better, it seems to be doing a good job. I don't know whether it's actually figuring out or whether it is just dreaming up things. But we see basically the gap between people's judgment, fear, and machine's competence narrowing down and bringing that to a level where people can themselves do just the way Six Sigma and other projects are there. They should be able to do it on their own, and then they will be able to come out with far more powerful ways of improving things. So that's the point at which I would say next 2-3 years the focus is going to be.
Yeah, sure. Thank you, Dr. Mr. Raj. And before I hand over to Rakesh, I have just one comment for the question answer. You know what? Being in the part of this discussion today, how I realized how far we have come. This was one topic on the chemical industry, and I thought probably we never used a single term on the chemicals. We talked about agentic AI. We talked about data knowledge. We talk about black box, and that's truly a transformation, right? If I have to replay this recording, and which is a testimonial that the transformation has already happened. It's just a matter of time that we will be. And I mean, imagine if we had this panel 10 years back, we probably were talking about the real chemical terms and all. But today's discussion, there was not a single mention of that. That's a testimony.
Very correct.
Right. Rakesh, over to you, if you can moderate the questions.
Yeah, so we have a lot of questions in the chat box. So let me take a question from Mr. Mit Shah, and he's asking which of the following use cases is the most mature. He has given 3 options: predictive maintenance, process optimization, and RCA and troubleshooting. Mr. Raj, would you like to take this?
Yeah, actually, we've had successes in all 3 areas. The third one, I would say, is more recent. The oldest is actually 2, process optimization, which I think that journey started almost 8 years ago. And now it's at a level of maturity, and the benefits are far higher. And so to that extent, I would say some part of this is purely, where in the race we started, as opposed to whether the particular tool or the methodology lends itself to a chemical plant. I'm sure all of them are applicable in some area or the other and can give benefits. So purely from where we started in our context, we have had enormous success in 2, which can be easily measured, and the monetary advantages are also clear. That may have been one of the reasons why we started off there, because ROI justification was tougher those days. 3, I would say, is fairly recent, but it's surprisingly good. Whether it is issues or failures or other things, we are able to put together, and that requires a certain degree of data maturity and ability to bring together data points from a variety of sources. But once that availability of data is there, then diving into it and finding reasons and making out a complete, properly formatted thing, GenAI is pretty good at doing.
So there are a couple of questions on one on cyber security, which I think Dr. Singh can take it. So first is only you have mentioned a lot on cyber security. One question I would like to ask, it was from Divya Shetty. Are Indian chemical manufacturers prepared for cyber attacks? From your experience, from speaking from the industry, are you seeing that awareness has increased?
Yeah. First thing is that awareness is very much increased. People knows it. Now, only thing is that when what I said about it, act. So we have to act. But if we talk about this with any leadership, with any meeting, correct? Like you have got your operational production meeting, standing meeting, still in the plants, that culture is there. If somebody talk about the cyber security, at least they listen, they give their attention, and top leaders are actually giving that much of time. What has happened, where, how, and I explained you. So I think Divesh has asked. It is there with what I have seen various companies, but the way you have to bring more attention is that what I said. No, whatever is happening outside, just make a note, publicize, tell your people. So this is said that learning from others. It's very important. And I also mentioned one more thing is that we all are in the same boat. Anyone can get attacked. That we should be aware. There is nothing called 100% security because every day new things are coming up. So what we want to have is that we should be cautious about it. We should be resilient about it. And the question what he has asked for that, I am saying many of the leaders, they are now giving time to it. They are understanding this situation. They are understanding that this is very important, like their output or production, everything. This is also equally important. Various people are there. There may be ranges like maybe 1 to 10 scale, somebody may be at 6, 7, correct? But that is also very good. I'm not saying 10, but 6, 7, it's very good. And people are giving that time. That's what is my take on this.
So there is one question from Mr. Nilesh Guhagarkar. So he's asking, how can digital and automation tools enable chemical manufacturers to accurately capture, monitor, and report the real-time emission of and carbon data across the manufacturing site? I think Mr. Chakravarti or Mr. Srivastav can take it.
So the question is, how can it is reported in real time? I think at present, with the help of advanced analytics, that getting the data in real time and the models are running, maybe in real time, but near real time. This is being calculated and continuously being monitored across the site, across central level, because most of the companies, they have committed to the net zero maybe in 10 years, 15 years down the line. So everybody are doing these things. Not only they are working behind to reach to the target of net zero, but for that they're already actually monitoring it, and now it is being monitored in real time. And the question was it how? I think all this, since the data are available and analytics and models are running, so they are now giving the real time information about how much carbon we are emitting. So this is being done, and if it is how, then it may take some more time to elaborately discuss, but it is being done, and most of the manufacturers are doing it.
So we will take two more questions. This is for, I think, Mr. Srivastav can answer. It's from Pranjal Patil. She is asking, how should companies validate AI-based recommendations before using them in safety critical and regulated manufacturing processes?
So I think there is no hard and fast written rule for that. every organization has developed their own ways and methodology to validate those recommendations. So what we typically do is we first work with historical data and see the how the recommendations are coming. Then we call it hot live, where near real time data comes, and then we kind of validate it at least 2 to 3 months. Once the confidence is there that yes, these 3 months we have seen that recommendations can be now converted into action, then we proceed and convert those recommendations into the live actions. So that's how we proceed, Mr. Rakesh. Yeah.
Yeah, I can actually add on these things a little bit. See, normally a pure machine learning AI model has some flaw because it does not understand the physics and the chemistry of the process. So for that, at present, what is being done is we are using as a guardrail the physics-informed machine learning, where the model's outputs are being validated with the physics and chemistry of the process. And so those are already being filtered out, which are not feasible, which are not safe. Those are already being filtered out by the model
Filtered out.
itself before it coming to the recommendations.
Okay.
Yeah.
So there is one more last question we will take, Mr. from Ashwin Kumar. And he is basically asking, a big question, just shortening up. So chemical industry has a unique processes and recipes. So there are two parts to his question. One is, are companies these days ready, are they patient to implement the systems instead of adopting ready-made off-the-shelf systems? So that is one question. And second is, are these companies ready to, take small scale companies as a partner for implementing the projects?
Yeah, let me
Yeah.
take that if you have not named any panelists. Yeah. Yeah, so that's a very interesting question, and very close to what we are doing here in ABG. In Industry 4.0 itself, we have almost 40 startups, right? So they are very, very niche in some areas. Sometimes they are generalist, but having 40 startups has given us, the kind of leverage we wanted in terms of either off the shelf or build from scratch approach, right? Now, where we deploy a kind of off the shelf approach, where we see the solution has already been proven in similar kind of industries, right? So that's the only one key takeaway. If the solution is already proven, and in next 2 to 3 months or some, we can show some value to our leadership team, let's go ahead with that, right? But if the horizon is more transformative, let's say we want to develop enterprise wide capability, uh, or the software components which will be used across multiple plants, multiple businesses, and futuristic, that's where we want to build it ourselves. We want to kind of implement those solutions ourselves, and hold the domain knowledge and internal knowledge within ABG, right? So that's where we are too much patient. I mean, we are waiting for that to get built in a longer period of time, let's say 6 to 9 months. Some components may be shorter period, but most of the components what we are building are longer term components. So that's, to give you an example, right now we are building our own knowledge graph tool, right? So there's a lot of off the shelf tools available, but since it's a great capability to have, and then in next whether 20 years, 30 years, or next 50 years, this tool will remain there as a key capability, enterprise capability, then why not invest and build in it, right? So those are the kind of discussions we do, and kind of this is the framework we apply.
Okay. I think we are now 5, and with this, I think we should close the day for today. And it was really an exciting, insightful discussion that we had today. And I would like to thank all our panelists for sparing time And contributing to this useful discussion, I would also thank our moderator, Mr. Subodh Jindal, for moderating this session. And all the participants who attended today's webinar. We will be taking this webinar live in maybe next week, and the link of which will be shared with everybody. And with this, on behalf of ASAP InfoGlobal Smart Manufacturing and Future Factory Expo, once again, thank you all for attending today's event, and look forward to more such interactions in the future. Thank you, and have a great day.